Today we will look at collinearity of points. Collinearity of points means, let's say, three points are said to be collinear if they lie on the same line. So if a given number of points may be 3 or 4, they are said to be collinear. That means they are collinear. So they are on the same line. That is what collinearity means. How do we know that if the given points are collinear or not is the usual question that we will be asked in our exams again and again. For example, there are some 3-4 ways in which we can figure out whether the given points are collinear or not. First one is, take the graph paper and plot all the points on a graph paper, and then we will see if all of them fall on a straight line, then we can say that they are collinear points. Otherwise they are not. But this we cannot do in the examination, because most of the times we will not be either given a graph paper or we are not asked to find out the collinearity using this method. But rather we will be asked to find out the collinearity of the points by calculating either through distances, that is by using the distance formula, or through slope, or through calculating the triangle. If they specifically mention any one of the methods, so we need to use only that particular method. If not, then we can use any of these three methods. Okay, the calculating the area of the triangle may not be like for the students who are studying below grade 10. This method may not be known, but both calculating the by distance formula and calculating by slope, they should be aware. Let's look at take an example and look at individual concepts one by one. For example, how do we calculate the collinearity of the points using the distance formula? So by using just the distance formula, can we say whether the given points are collinear or not? Yes. How can we say? For example, if A, B, C are 3 points on the line in that order, then AB, that is the distance between A and B, that is AB, plus BC, that is distance between B and C, must be equal to AC. So that is very evident, isn't it? Let's take this line and then we say this is A, and then we have this as this point is B, and then we have one more point here which is C. So these are A, B, C are 3 points. Then obviously this distance plus this distance must be equal to this distance. So that is what it is. So if we can calculate AB and then calculate BC, add both of them, if that is equal to AC, then we can conclude that they are in the same line. So if they are not on the same line, this condition will never be satisfied. Let's take these 3 points which are not on the same line. Then if I calculate AB and then BC, that will never be equal to AC. So this condition, AB plus BC is equal to AC, will be satisfied if and only if they are in the straight line. So that's a one criteria. Let's take the example. If A is equal to 6, 4, B is equal to 4, 2, C is equal to 1, -1, then check for the collinearity. That means see if they are collinear or not. So using the distance formula, we know the distance between the 2 points x1 and y1 and x2, y2 is given by x1 minus x2 square plus y1 minus y2 square, square root of. And then calculate the distance between A and B. Distance between A and B is x1 minus x2 whole square, that is 6 minus 4 whole square, and y1 minus y2 whole square, that is 4 minus 2 whole square. 6 minus 4 is equal to 2 square, 4 minus 2 is equal to 2 square, that is equal to root 8, that is equal to 2 root 2. Similarly, the distance between BC is equal to x1 minus x2 whole square, and then y1 minus y2 whole square, that is 4 minus 1 whole square plus 2 minus of minus plus 1 whole square, that is 4 minus 1 is equal to 3 square, 2 plus 1 is equal to 3 square, that is equal to 9 plus 9, that is equal to root 18, or 3 times root 2. Then distance between A and C is x1 minus x2 whole square, and then y1 minus y2 whole square, that is equal to 6 minus 1 whole square plus 4 of minus 1 whole square, that is equal to 5 square plus 5 square, that is equal to, this is 50, this is not 8, this is 50, because 25 plus 25 is equal to 50. So 50 are 5 root 2. So when we take 50, so that will give us 5 root 2. So these are the distances between AB, BC and AC. Now if we add AB and BC, then we will get 5 root 2. So that means since AB plus BC is equal to AC, A, B and C are lying in the same straight line, or they are said to be collinear, and in that order, that is A next followed by B and next followed by C will lie on the same straight line, that is collinear. So this is how we will check the collinearity of the points using the distance formula. The other method is by calculating the slope. So we can also see if A, B, C are lying on the same straight line, and then if we calculate the slope between A and B and also the slope between B and C, so if both are equal, AB, the slope of AB and the slope of BC are equal, then we can conclude that both of them lie on the same straight line. If they don't lie on the same straight line, if it is AB and BC is like this, then the slope of AB will be obviously different from BC. So the slope of AB and the slope of BC will be equal if and only if ABC lie on the same straight line. So that is the concept that we are going to use. So again we will take the same example, that is equal to A is equal to 6, 4, B is equal to 4, 2, C is equal to 1, minus 1. Slope of a line when 2 points are given, that is x1, y1 and x2, y2 are given, can be found out by calculating y2 minus y1 divided by x2 minus x1. Let's calculate the slope of AB. Slope of AB is equal to y2 minus y1, that is y2 minus y1 divided by x2 minus x1, that is equal to 2 minus 4 divided by 4 minus 6, that is equal to minus 2 divided by minus 2, that is equal to 1. So similarly calculate the slope of BC. Slope of BC is equal to, so BC y2 minus y1, that is equal to minus 2 minus of minus 1 minus 2, that is equal to minus 3, and x2 minus x1, that is 1 minus 4, that is equal to minus 3 divided by minus 3, that is equal to 1. So slope of AB is equal to slope of BC. Since both of the slopes are equal, so then ABC are said to be collinear. So this is how we find out the collinearity of the points using slope. The next method is calculating the area of the triangle. So the formula for calculating the area of the triangle we all know, that is equal to half B and H. But provided we are given base and height of a triangle. But there are times where we are given only the vertices. When the vertices are given, how can we calculate the area of the triangle? We have a formula to calculate the area of the triangle. That formula is half x1 y2 minus y1 x2 plus x2 y3 minus y2 x3 plus x3 y1 minus y3 x1. So this is the formula to calculate the area of the triangle when 3 vertices are given. The concept that we are going to use here is, for example, if 3 points are lying on the same straight line. So if these are the 3 points, that is A, and then this is B, and then this is C, if these are the 3 points lying on the same straight line, they can never form a triangle. It is not possible to form a triangle just using a straight line, isn't it? So they can form triangle if and only if they are not lying on the straight line. So if they are not lying on the same straight line, then it is possible to form a triangle. That means the area of the triangle is 0 because there is no triangle being formed if the points are lying on the same straight line. So that is the concept that we are going to use. If the area of the triangle is 0, that is an indication that those 3 points are lying in the same straight line. So we will calculate, we will take x1 is equal to 6, y1 is equal to 4, x2 is equal to 4, y2 is equal to 2, and then x3 is equal to 1 and y3 is equal to minus 1. If we substitute the x1 y1 and x2 y2 and x3 y3 in this above equation, we will get half of 6 into 2 minus 4 into 4 plus 4 into minus 1 minus 2 into 1 plus 1 into 4 plus 1 into 6, which will be minus 4 minus 6 plus 10. This is modulus. Modulus means whatever the value that comes inside, whether it is positive or negative, we will take only the positive part of it. So then minus 4 minus 6 is equal to minus 10, minus 10 plus 10 is equal to 0, 0, modulus of 0 is also 0, and then 0 multiplied by half is equal to 0. That means the area of the triangle formed by these 3 points is equal to 0. That means they are lying in the same triangle. So these are the ways in which we can find out whether the given points are collinear or not.